Math for college students. This is one of the last sections that we want to look at when we're talking about rational equations or rational expressions. Want to consider rational equations. So if you think about it, we've talked about multiplying, dividing, just general simplifying, adding and subtracting rational expressions. And now we're looking at rational equations. That means algebraic expressions that look like a fraction that are written as an equation. And what we need to do here is just create common denominators throughout. So everything here can multiply to 6k squared. For example, if you have 1 over 6k squared and 1 over 3k squared, 1 over k, what we would multiply 3k squared by would be 2, and that would give us 6k squared. What we would multiply k by would be 6k, and that would give us 6k squared. So look at what you now have. 1 over 6k squared is equal to 2 over 6k squared minus 6k over 6k squared. I know it looks really challenging at that point. And the 6k squared is actually something that we can now ignore. We don't need to look at it at all. If the denominators are the same, then we can simply ignore them and just focus on the numerator. So 1 minus 2 is equal to 6k. Oh, I'm sorry. I kind of did a bad job as I crossed that stuff out. It looks like it's 1 is equal to 2 minus 6k. So we subtract 2 from both sides, we get negative 1 is equal to negative 6k. Divide both sides by negative 6, and we get 1 over 6 is equal to k. That's your solution. Now, as we look at this example, it's important to remember why we can do that. If I have this equation, x over 5 is equal to 3 over 5, and I say, what is x? What would x be to make that equation true? You would say, well, x has to be 3. See, you can simply ignore the denominators when they are the same and focus on the numerator. Now, if I had x over 5 was equal to, say, 6 over 10, now you can't just say that x is 6. That doesn't work because the denominators aren't the same. So as soon as you make the denominators the same, you can just focus on the numerator. Look at number 2. These multiply to 5x. So if you have 1 over x is equal to 6 over 5x plus 1 over 1, what we would like to do is we would like to create a 5x in the denominator. So I'm going to multiply the top and bottom by 5. I'm going to multiply top and bottom by 5x. What we have is 5 over 5x is equal to 6 over 5x plus 5x over 5x. The denominators are now all the same. As the denominators are the same, you can ignore them and just focus on the numerator. 5 is equal to 6 plus 5x. Subtract the 6, negative 1 is equal to 5x. Divide by 5, x is equal to negative 1/5. That's my solution. Sometimes you may have to set up a little bit of a factoring option. Here we have 1 over m times m minus 1 plus 1 over m equals 5 over m times m minus 1. I'm going to multiply the top and bottom by m minus 1. Now the denominators are the same. 1 plus m minus 1 equals 5. That's what this equation becomes because the denominators are now the same. 1 and negative 1 is 0, so you get m is equal to 5. Try one more example. 1 over 1 equals 1 over x times x plus 2 plus x minus 1 over x. This one's a little bit more involved. Notice that they all multiply to x times x plus 2. So I'm going to multiply top and bottom by x plus 2. And over here, I'm going to multiply top and bottom by x times x plus 2. If you notice now, all the denominators are the same. So we're going to be able to take those and ignore them. And we're going to be able to focus on the numerator, which is x times x plus 2 is equal to 1 plus x minus 1 times x plus 2. Notice in this situation, x times x is x squared. X times 2 is 2x. We have 1. As we multiply this out, we get x squared. Negative 1x and positive 2x make 1x. And negative 1 times 2 is negative 2. X squared plus 2x equals, I'll gather my like terms, 1 and negative 2 are both like each other. So negative 1 plus x squared plus x. Notice this equation is of second degree, meaning that the exponent is 2. As soon as you have an exponent higher than 1, you need to gather everything on the same side. So I'll subtract the x squared over. And once I do that, those actually cancel. And I get 2x is equal to negative 1 plus x. I'll just subtract the x over, and I get x is equal to negative 1. And that is my solution. So, solving rational equations, it looks really challenging. We'll practice in class, but once you find common denominators, turns out that it works out pretty nice. We'll see you guys later. Have a great day.